Hi, everybody. You guys want to start with questions from 3-1 stuffs? Hey, it looks like you're ready to go.
Yeah. 27.
Yeah. You got it 3? Okay. Remind me, we'll do 27 here first, and I'll come right back and get you to Lucas. Try my hardest not to forget anybody. All right. And you said 27, right, Peyton? Okay. So I'm just going to have to FOIL it out to start. So again, I'm going to use my binomial expansion. So again, on a test or quiz, I would not give you something where it's either really time consuming or you need to use the binomial expansion to do it. Unreasonable in a time setting. Like in a homework, I think it's fine. It's a little bit tedious, but it's what you do. We're gonna be 2 sections later, we can do this without a binomial expansion. So that's coming. Kind of exciting, but we're not there yet. So we clean up now a little bit. So x squared times x to the negative 1 is just x. X times x to the negative 2 is x to the negative 1. And x to the negative 1 cubed is x to the negative 3rd. And so if we now take the derivative, we have that. Does that feel okay, Peyton? And from there you could stop. I'm sure the answer in the book looks neater than that. But as far as I go on my tests and quizzes that you guys will take, basically when the calculus is done, you can stop. You don't have to make the answer as pretty as possible. And that's kind of the policy on the AP exam for their free response questions. They are not going to grade you down for not getting the most simplified answer. But what they will do is they'll mark it, they won't give you points if you simplify something and get an incorrect answer, even though you had it correct, and then you tried to algebra it up and you made a mess out of it, now it's wrong. Then they wouldn't give you the final point. In general, on the AP exam, on the free response questions, I plug numbers in, I stop. I do the calculus, I stop. I don't simplify anything, I don't crunch any numbers, even on the calculator sections. I don't bother with it unless that number is part of something else that I'm going to use later where it makes sense to let me just get a number out of this thing. But they will not grade you down because you said the answer was 4.5 squared minus 3.7 over 5.6. If you leave it as that, it's fine. Right? So here's where I would say stop. What's the catch though? If it's a multiple choice question, probably the answer's not going to look like this. They'll have the cleaned up answer. So that's the place where they're going to check to make sure you can simplify answers if it's a multiple choice, but they would not require it on the free response, nor will I. Yes?
So when something, if I find a derivative of something and it's in parentheses, not just one thing, does that mean we have to FOIL it and we can't just do bring it forward and
Correct, because what you have here is the composition of 2 things, right?
Yeah.
So this is oh my goodness. Where's my, yes, thank you. where h of x is really like f of a g of x, where f of x is like x cubed, and g of x is like the inside stuff, that. And we don't know how to do that kind of a derivative yet. We will, but we haven't learned that rule yet, and how to handle something that's like a composition of two function types. Does that make sense? So once it's all foiled out and there's not a composition going anymore, then you can just distribute the derivative through. Is that feel good? Okay. Follow up on 27 before we go to Lucas. Yes.
Is that first the binomial? Is that just like the Pascal's triangle thing?
So the coefficients are coming from the rows in Pascal's triangle. That is correct. Yes. Because the combination, like n choose k, is the k position on the nth row in Pascal's triangle. That's another way to come up with those combinations. There's a formula too. It's like n factorial divided by k factorial times n minus k factorial or something. But you can also generate them by looking at the rows on Pascal's triangle.
So it's not like if we had to FOIL, you wouldn't ask us to do that. It would be just like.
I mean, if I was to give you this exact same problem on a test, I'd just make it squared so it's not tedious. Because it's the same problem, it's testing the same thing. Do you know to like expand this out before you take the derivative? That's what we're checking here. I can check that just as well with a squared as I can with a cubed. And then it doesn't take 5 minutes to FOIL the thing out, like condense everything back together and it's the same question, just faster. It's less tedious. The time setting, it's like checking what I need to. I don't care if you do a triple FOIL or do the binomial formula. That's not what this test is. I try to really hard to limit, the extra tedious stuff that you have to do that's not germane to the calculus. I don't mind if the calculus is tedious. That's what we're testing on. I don't want to make this, obscure in a high school setting algebra skill, the thing that's going to be the roadblock to finishing the problem. You know what I mean? Lucas 23?
Yeah.
Okay. I think that was on a no, it's in that same block of problems, right?
Yeah.
Perfect. I don't know what I'm doing. All right. We'll change the color. Oh, I can't do that. Over here. We'll change the color. We'll look at 23. So again, for this, the way it's currently written at the start, where it's written as the quotient of two functions, I can't handle that with the derivative rules I have available to me right now. That'll change after today. But even after today, I would still choose to do this in the way that we're going to. I'm going to simplify this thing. Since the denominator is a monomial, I can just rewrite it as 3 fractions that all have that same common denominator. And I rewrote the square root of x as x to 1/2. So far, so good. We do some reducing, and we have x to the 3/2 plus 4x to the 1/2 plus 3x to the negative 1/2. Everybody happy with how I produced this? That was all just to get into a form where I can use my derivative shortcuts now. So when I take the derivative of this, it becomes like dy dx, and then I have 3/2 x to 1/2 plus 2x to the negative 1/2 minus 3/2 x to the negative 3. Alice. Factoring the numerator will not help you in this problem. I mean, yeah, because either way you're going to be stuck with like a product. Absolutely. Yeah, we just don't know. We don't have a rule to do the product of two functions. We will have to do that. So it's coming. So sure, factoring could be helpful. Typically for a polynomial, probably not. But you never know, right? Like I don't want to rule that out, but often like taking the greatest common factor out can be helpful so you don't have, instead of having 3 products, just having 1 product often is quite helpful. But typically like factoring a polynomial, probably not to take a derivative. What do you guys think from the 3-1? This went pretty well, I hope. Yeah, and I would just stop there. I mean, like, I'm sure the textbook cleans this up. Yeah, I don't know that you need to. Like, if it's a multiple choice problem and you get this answer, you look at the multiple choice and it's like, oh, everything's got a square root and a common denominator. Okay, I guess I have to keep simplifying this to make it pretty. And we can do that if you want to see how to do that. But if it's a free response question for me, you can stop. Do you want to keep going, or are you good? Okay. All right, what do you guys think? You ready to quiz it up for 3-1? Let's go. You picked good ones to look at, because the tricks that I just used on the homework quiz resembled very much the tricks we just looked at, so good job seeing ahead. Oh. Well, it's how fast this is, not right? Potentially, but once you've got it, really quick on it. It's not about being easy as much as it is fast.
I said, no, I said I'm paying him.
Wow.
I didn't say
Wow.
What are you paying him for?
to get for class.
That happens. You're probably still drying out.
I was at practice and I had soccer pictures. So yeah.
A lot of stuff.
Yeah.
Let's start here. So today, we're going to talk about the product and quotient rules for derivatives. So essentially, we're going to cover if I have the product of 2 functions, how do I do that? Or if I have the quotient of 2 distinct functions, how do I do that? Now, in some situations, you'll still be able to algebra your way through to avoid having to use these rules, right? If I have x times 1 over x, I don't have to use a product rule on that. I can just multiply them together and get 1 and the derivative of that, right? So just because we have these tools doesn't always mean they're the best tool for the job. Oftentimes, some algebra beforehand is preferable to breaking out the product or quotient rule. But in many cases, it's unavoidable, right? You have to use it. So we're going to prove this. So essentially what we're saying here is that, like, that the derivative of a product of two functions is the first function times the derivative of the second, plus the second function times the derivative of the first. You guys see that? Is this something you need to memorize? Oh, yes. Yes, yes, yes. The rule we'll use frequently is one you have to be really comfortable with. You need to have it memorized. Add it to our list of things to memorize, which I know is getting quite long, but it's the way the cookie crumbles sometimes, folks. I don't know what to tell you. All right, we're going to prove this theorem. Would I ask you to be able to repeat a proof on a test? Will you have to do proofs in your homework? I don't really think so. Very rarely. If you are planning on taking like 4 or 5 years of mathematics as a college student, will you have to prove things? Oh, yes. So this is mostly just to get some exposure to the technique on what we're doing, some of the tricks that we'll use, so that when you see it again later, that you're like, okay, I remember kind of doing that. So if I want to prove one of these derivative rules, I'm going to be using my limit definition for a derivative. Everybody okay with what I did there? So I'm taking the derivative of f of x times g of x. I'm going to have f of x plus h times g of x plus h minus f of x times g of x all over h. So my trick, what I'm going to do here is I'm going to add and subtract the same thing inside of this fraction. I want to do minus here. And actually, let me do this right now. And I'm just going to think about this now as two fractions with a common denominator. So notice that I subtracted f of x times g of x plus h, and then added it right back. Right? It's equivalent to doing nothing at all. You guys see it? So if I look at the two things that I've grouped, notice that I have a g of x plus h in common with each term. Over here, and I have an f of x in common with each term over there. Ready to notice? Guess what I'm going to do with those? I'm going to factor them out, just like a greatest common factor. Everybody so far so good? That's what I've done. And then I guess I should probably, we're taking the limit of that whole thing. What are those things that I just highlighted? It's the difference quotient. It's the definition of a derivative, right? So what I'm going to do is I'm going to use my limit laws to push the limit into each part of this sum. Everybody okay with what I did there? That is our definition for the derivative of f. That is our definition for the derivative of g. What's the limit of f of x, or as x approaches 0 of f of x? Is there an h for me to sub that into? So relative to the variable h, f of x is a constant, right? The limit of a constant is? Nope. The derivative of a constant is 0. The limit of a constant is the constant, right? So this f of x just plops right down. I bring down the plus. Here, the limit as h approaches 0 of g of x plus h. I can just do a direct substitution, right? X plus 0 is x, so I just swapped through g of x, and there's my, what I was trying to get to. Maybe I have it in a different order than, but it's addition, right? Like whatever. Is everybody okay? Let's practice using this rule now. Okay, we've proven it. So it says, if f of x is equal to x times e to the x, find f prime of x, the derivative. Notice that x times e to the x, those are distinctly different functions where there's no like terms to combine, right? It's not like I have x times the square root of x, where I'm like, oh, if I rewrite the square root of x is x to the 1/2, I can multiply those together, just make it x to the 3/2, and then I don't need a product rule anymore. I can't combine x and e to the x in any kind of way, right? So this is Scream's product rule, where my f of x is x and my g of x is e to the x. Everybody see it? So I'm going to have e to the x times the derivative of x plus x times the derivative of e to the x. Is everybody okay with how I've written out? This is a step, right? This is a d.
Oh.
But it's like we use like the script d. It's not supposed to be like the letter d. So it's whatever. It's a d. However you want to write it is okay. It's okay with my work. Now, what's the derivative of x? 1, correct? And what's the derivative of e to the x? E to the x. Is everybody happy with what we did there? Bless you. Welcome. Far so good? Part B asks for the nth derivative of this. Can we actually compute that? No. What do you suppose we're going to do? We're going to take the second derivative and probably a third derivative and look for a pattern to see if there's a relationship between what we're getting and the level of derivative we're taking. And then just kind of make a guess at it. Is everybody okay with that plan? So I'm taking the derivative of this thing, right? Derivative of e to the x is e to the x. The derivative of x times e to the x. Well, hey, that was what I started with, wasn't it? So isn't that just the derivative? Yeah. Okay, well, swell. So it looks like I'm going to have 2 e to the x plus x e to the x. Why do that? So I'm taking the derivative of this guy, right? So the derivative of e to the x is this e to the x. The derivative of x e to the x, that was the problem we started with. So it is this value, right? Does that feel good as to where everything came from now? Yeah, no problem. Again, if I do something and you're like, yeah, I didn't quite catch it, what happened there? Stop me and ask. Totally fine. Now, I think at this point, you probably see what's going to happen, but let's do it one more time just for grins, okay? So let's take a third derivative. So we're differentiating this thing here. The derivative of 2e to the x is 2e to the x. Very good. Derivative of x e to the x is that guy right there, the first thing we found. And when we combine this together, we have 3e to the x plus x e to the x. Does anybody see the pattern that's happening here? What is the pattern happening? You just pick up another e to the x term every time we differentiate. So we might say then that our nth derivative then is going to be n times e to the x plus x e to the x. Again, we didn't compute that directly. We just did a couple of derivatives and like, I got a feel for what's going on here. I see what's going to happen.
So is that like a rule for just this problem?
Correct.
Like
This is really works for just this problem because of the nature of it, where basically you just end up with an extra e to the x term each time. That's not typical, but it's a function of this problem. So like if you're asked something about an nth derivative, you better hope that there's like a noticeable pattern as you take these derivatives because there's no other way to go about doing that. Not a good way that I can think of offhand, anyway. All right, let's do another one. F of t equals square root t times a plus bt. Do we need to do a product rule for this? Now you can, but do you need to? You said no, why not? Alice, was it you mumbling no? Okay, what could we do instead of doing a product rule here? Yes, and then yes. And you do that. Probably easier than going to the product rule, though not wrong to do the product rule there. To be clear, it is okay to do that. I feel like it's a little bit like using a sledgehammer to drive a nail in, but it'll do the job. It's just a little bit more tool than you really needed for the situation. You guys see what I'm saying? This will be a common theme of doing derivatives. It's like, should I make the algebra, do a little bit of algebra to take away some calculus, or do no algebra and have more calculus to do? Very common thing. So it's like a balancing act of like you figuring out and seeing like, oh, look at this, I can get away with not having to do all the calculus by doing a little bit of, pre-algebra stuff to start, which is good. Typically, that makes your life easier, less prone to make mistakes. All right, f of x equals square root x times g of x, and then we're given some information about g of 4 and g prime of 4, and asked to find f prime of 4. So if we want f prime, we're going to have to take the derivative of f. So we'll start by doing that. Now, square root x times g of x, 100% we have to do a product rule here, right? Like, there's no way I can combine g of x that we know nothing about with like a radical. So we're going to have g of x times the derivative of x to the 1/2 plus x to the 1/2 times, well, do it this way, the derivative of g. Just write it that way. Everybody okay? And the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then I'm not touching the other piece. That looks fine the way it is. Everybody feel okay with what I did? Now, I could simplify this more, but I'm not going to. Mostly because it's not asking me for f prime of x. It's asking me for f prime of 4. So I'm just going to go back and plug 4 through this anyways and get a number for an answer. I don't care how neat this is. It's going to get, if I spend a bunch of time making that neater, it's just going to be plugging a number in and simplifying down to get a number anyway. Like, why bother with it? Everybody good with how I plug things in? Okay, it says g of 4 is 2. What's 4 to the negative 1/2? Nope, not 2. 1 over 2, right? Because the negative exponent flips it, right? And I have 1/2 times 1/2, so that's going to be 1/4. And then 4 to the 1/2 is 2. And then g prime of 4, well, that's 3, we're told. And we get 6.5. Let's go over there. Okay. What if we have the quotient of 2 functions? I'm not going to prove this one. It's kind of a nightmare. Well, it's not. It's just like, it's messier than I think is productive. It's kind of a lot of time. It's a little messy. I don't think much is gained from it. We did the product rule. The thing to remember here about the quotient rule is there's subtraction, so the order of those 2 terms in the numerator really matters. Okay? So one way that you can try to remember this is if I think of g of x as low, it's on the denominator, and f of x is high, because it's in the numerator, you fit this to like the U of M fight song and say low times d high minus high times d low all over low squared. And you kind of pump that into the U of M fight song. I've heard people do that. It's the beat. Yeah. So I'm saying like high times d low for the derivative of the low minus low times d high all over low squared. Let's practice using this quotient rule now on this next piece. So we're going to find the derivative of y. I could write that either as y prime or dy over dx. Both of them mean the same thing, means the derivative. Let's write it this way this time. So if I use the quotient rule, I'm going to have low times d high minus high times d low all over low squared. You okay with how I plugged the things in here? Give you a moment here to copy and process, because it's a little bit of a complicated rule to get a feel for like where things are going and what we're doing. I haven't really done any differentiation yet, right? I just cleared the quotient part, and now still have to differentiate pieces of that quotient. Everybody good? So d means derivative of the function, the low function, which is the denominator. Does that Okay? It's just like a way of trying to memorize the formula. Lucas? Right. Correct. So I have low times, oh, yeah, did I write that down wrong, didn't I? Good. Great Googling. Moogly. Yes, of course I did. That makes perfect sense. Why would you not screw it all up, Mr. Kulik? Goodness gracious, thank you. You see me doing something wrong, it's like that I think you just like something what? Like stop me before we get too far, making a mess out of this thing. Low times d high minus high times d low, all over low squared. Thank you, Lucas. That's probably why you're all looking at me so like, what? 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 Yes. Yes, thank you. About screwing stuff up. Woo. Good catch. All right, you ready to keep going on this? Okay. Derivative of x squared plus x minus 2 is? Oh. 2x plus 1, right? And what's the derivative of x cubed plus 6? 3x squared. So just in an effort of like compacting my work a little bit, I'm going to write those things above the derivatives. Now I'm going to multiply things out, combine my like terms, and see if I can reduce it all. Technically speaking, at this point, the calculus is done. But I'm going to tell you right now, if this is a multiple choice question, there's no way in God's green earth that like this is going to be the answer they're going to write down. They're going to FOIL everything out, combine like terms, reduce if possible, even. Oh my gosh. I know. So what do we have? We have x to the fifth plus x cubed plus 12x plus 6 minus 3x to the fourth minus 3x cubed plus 6x squared all over x cubed plus 3 squared. Everybody okay with what we did? Oh, yeah, I don't know. Doing dumb things. 2x to the fourth, right? That's better. Thank you. Better double check everything else now. Okay. I think everything else. You guys all double check me? Yee! All right, combine some like terms here. What am I going to have? I'm going to have negative x to the fourth, and then negative 2x cubed, and then a 6x squared, and then 12x, and then a plus 6. Everybody feel okay? If I check, so if I want to try to reduce this stinks, right? To try to reduce, because factoring that numerator is up. Like a 5-term degree 4 polynomial. That's your worst nightmare because it's not groupable. Like there's at least an even number of terms. Let's try to factor by grouping real quick. That's pretty quick and easy. I can usually see if that's going to work or not just by looking at it. Here's the good news. As far as reducing goes, all we have to do is find out if x cubed plus 6 is a factor, right? even if that thing factors, I don't actually have to factor, I just have to figure out if x cubed plus 6 is a factor, because that's the only thing that'll reduce. So I could just do this one polynomial division to check it. I don't really need to, though. If this is a multiple choice question, if that's not the answer, if it's a degree 2 over, or I'm sorry, degree 1 over the x cubed plus 6 to the first, pretty sure I know what would happen. And in that case, if there's multiple of those, I could just FOIL, take the numerator times x cubed plus 6 and see which one gives me my numerator. I probably wouldn't ever try to factor to do the long division just because it'd be quicker to just check the reverse direction. And if it's not a multiple choice question, you don't need to worry about it. Does that feel fair? I just want to talk through how I would approach something on a test setting. Do you guys get what I'm saying or no? Let's keep on plowing ahead then. It says find the an equation of the tangent line to the curve, blah, 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 at the point 1, 1/2 e. So the tangent line, we need an m, which will just be the derivative evaluated at 1. But it's okay there. So I got to take the derivative. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. There. Now notice that I don't need the equation for the derivative at all. So I'm just going to do the fairest bit of calculus to get me down to the calculus is done, and then I'm plugging numbers in, and I'm not fucking around with simplifying this because it does not matter for this problem. You guys see what I'm saying? If a number is getting plugged in, I don't care about things being properly simplified. Ooh. We got a zero solved there. That's fun. Why is that fun? Yeah, it just makes the tangent line super easy to write. Done. Right? Ooh. It's always exciting when it works out nice like that. And then this pink box down here at the bottom is just condensing all the derivative rules you've seen to this point. They're using the prime notation rather than like a ddx or whatever, but it's still the same rules that we've seen to this point consolidated into one place for you. D over dx means it's the operation for take the derivative. So like how like the dot means multiplication, or like the radical means square root. ddx means to the derivative. Means we're taking the derivative of that thing. that feel okay? And if you take the derivative of something like how it's d over dx, if you take the derivative of something without an x, something else happens. That's why we're getting dy dx's as a way of writing the derivative of y. We'll talk about that when we get a little bit further into this chapter. What that means. But that's exactly the right idea. All right, guys. So here's the 3-2 assignment. When would that be due? Next Sunday, not this Sunday, right? So 3-1 and 2.8 are for this Sunday, right? 3-2 is next. I also made a delta math for chapter 3 that we'll work on in class we'll talk about some review stuff, and then you'll work on the delta math in class next class, because we are going to be a day ahead of the B period, the B day class, because of the senior project. So you guys will have a day next week where we're basically gonna twiddle our thumbs and just kind of work on stuff. So you have that coming up. So we'll do that. We'll have the review, and I don't think there's a time for a test next week. It'll probably be the week after. But this is the last topic before test 2. So I think for B day to fit their stuff in, we need to do they need to do 3-2, and then they need to do the review. They only have 2 days next week because they have Mondays shoot up for them. So I think your guys' review will be Thursday and test will be Monday. Then is what it would look like. Sure. Let me.